So my presentation today is Tales from the Road. First of all, I want to thank you for inviting me to speak today. It's my pleasure and my privilege to speak at this honor for Mike Thomas. Just thought I'd start with the real quick timeline of my experience with Mike. And my very first interaction with Mike was when I was a research engineer at W.R. Grace. I had just finished my PhD. And in fact, it was Doug and Mike that came to visit us in Cambridge. I remember they both gave great technical presentations, and when I walked out of the room, I had one thing in mind, and that was the picture of the moose that Mike put in the middle of his presentation for no reason and just said, "This is a moose." I kind of liked that. It stuck with me for a while, not only the technical goodies I got, but the humor. Didn't have really any interactions with him for several years until I moved to Texas. And in the year 2000, I reached out to Mike because we had a TxDOT project that we were bidding on ASR. And since then, we've been working continuously since 2000. We have a 20-year plus collaboration that's still ongoing. Whole bunch of different TxDOT projects, mostly related to concrete durability. In fact, Mike was honored with this great bumper sticker because he's done so much great work in Texas. So he's a true Texan now. And our work extended beyond TxDOT projects to funding from ICAR, Federal Highway, and more recently, the NCHRP project with Jason and Thano and myself and Ben. And in addition to that, I've also had the pleasure of teaching training courses with Mike for most of the last 15 years, both for industry and academia. There are occasions that we actually will put on small skits, and this was the one that we when we were pretending to be admixture salesmen. So I guess the question is, would anybody buy admixtures from us? I would tend to doubt it, but we'll see. Sorry, my screen here. There we go. So Mike's had a tremendous impact on me personally and professionally. When I first arrived at University of Texas, you can see this picture. We had a lot of space and a very ugly, unusable lab. And one of the things I learned from Mike is that exposure sites are absolutely critical when you're doing durability. So if you fast forward 20 years later, we have the original footprint of our buildings, but you now see a recent map here showing a very large ASR DEF sulfate exposure site. We have ones for bridge deck cracking, ASR for existing structures, carbonation, and more ASR. So I've learned from Mike, you don't ask, you just take. And so far, nobody has tried to take any of our land back. So we've extended our exposure sites beyond Austin. We have sites now along the coast in Port Aransas. We also have a West Texas site. Mike and I have been frequent visitors to the marine site, but neither of us have made it to the West Texas site. And you might want to guess, you could probably guess why. But these exposure sites have had a great impact on our program, and you know, I really honestly would say we wouldn't be doing any of these sites without Mike. Most recently, this marine site, which is really unique to have some space on the Gulf of Mexico. What I am going to be talking about today is mainly just focusing pretty quickly here on the work that we did under a multi-year federal highway project. The goal of this project was to look at technologies for trying to slow down ASR in field structures. This included bridges in various states, as shown here, pavements, highway and bridge barriers, and we also included 2 outdoor exposure sites as part of our field trials. It's personally one of my most proud accomplishments is convincing the Federal Highway Administration to allow us to build an exposure site in Hawaii, and I think collectively, as a research group, we're very happy of that decision. And what I'm going to focus on today are just a couple of these trials really quickly, and then we'll move forward. These federal highway trials, as I said, covered a whole range of different structure types and geographical locations. I'm going to just focus on just a couple of these in Idaho, in Massachusetts, and then a little bit of work in Texas as well. First and foremost, I should mention, and I think Kim just mentioned this recently, that this funding was actually allocated through some federal highway funding, and it was earmarked for lithium research. Lithium, we know, has been shown to be effective in reducing expansion in new concrete, provided you put enough in and provided that the aggregate responds to it. And the mechanism by which lithium prevents ASR is still not completely understood, but we do believe it has to do with the modification of the nature of the gel, where the lithium will be incorporated into the alkali silica gel and then creates a much less expansive gel. And the fact that it actually works on the existing gel has created some interest over the years in trying to use this as a post-treatment for existing structures. There has been work done to date to show that in small laboratory samples, you can reduce ASR expansion. But as I note here at the bottom, we have to keep in mind that the vast majority of this work has been done on very small samples with full immersion, which is certainly not realistic with regard to field structures. When we first started doing this work with Federal Highway, there had been quite a few field trials prior to this in the US involving lithium as a post-treatment for concrete. Almost all of this work involved pavements. Some work was done on bridge decks. The problem is, historically, there has been essentially little or no data to confirm whether lithium is effective in this post-treatment regime. And that's kind of the way we came into this project, with that as a backdrop. And one of the things we started off first was looking at a freeway on I-84 in Idaho, which I will describe here next. So this is a freeway in their mountain home, Idaho, that has suffered significant ASR-induced expansion and cracking. It was an ideal site because it was relatively long and it had pretty large sections that had different levels of damage to date. So we were able to pick essentially 3 different degrees of severity, and then for each of those degrees of severity, we did topical lithium treatment. In some cases, we did multiple treatments, and then we did full-scale monitoring. When it comes to monitoring in the field, we do a lot of in situ measurements where we embed gauge studs on the into the concrete for expansion measurements. We also track cracking and crack widths with a crack mapping technique. And then later on, we come back and pull cores to see how much lithium penetrated into the concrete. When we first arrived in a mountain home and started to drill into the pavement, we had a heck of a time with this pavement. Here you can see Mike trying very, very diligently to try to drill into that concrete, and it just wouldn't go. In fact, we were just eating through the drill bits one after the other, which led to discussions about the geographical formations, geological formations in Idaho. And we had all kinds of detailed studies, but didn't have a lot of time for these studies, given that we had lane closures and we had to get our job done. So as a good team, we sent our crew to various Home Depots throughout the state to pick up every masonry bit we could find, bring it back to us. One of my grad students was there and came back with the drill bit, and he asked if he could give it a shot, at which point he realized that we were drilling in reverse. So that's one of our names that we call our team, are the reverse drillers, and that's why. So ultimately, when we reversed the direction of the drill, everything worked fine. So what did we learn from Idaho? Well, we learned that lithium doesn't penetrate much into concrete if you topically spray it. Shouldn't be a surprise, especially when you're applying a very small amount of lithium at 1 or 2 occasions, say. If you compare the amount of lithium that penetrated into the concrete, you'll see that really only the outer 1 or 2 millimeters received enough lithium to be above the threshold that should be effective in terms of suppressing ASR. And not very helpful when you consider that upper 1 or 2 millimeters are already carbonated, so they already has a low pH, and it's succeeded in reaching the one part of the concrete that doesn't need it. We then took some large full depth pavement sections from Idaho back to our lab, split them into different cubes to create miniature exposure blocks, and we then sprayed lithium in different combinations. And once again, we saw that the depth of penetration was, at best, 1/4 of an inch or 1/8 of an inch. And it's consistent with what we saw in the field and consistent with what you would guess logically. We took it a step further and decided, well, why don't we just cast full outdoor exposure blocks with known materials and known reactivity and look at the best possible case scenario ever, which would be to continuously pond your block with lithium nitrate solution, which we did in the middle sample. The left is a control. And on the right-hand side, we did something slightly more practical. We sprayed it every week for 32 weeks. And at the end of this time period, lo and behold, nothing worked. In fact, both of those sprayed samples expanded more than the control, which perhaps suggests that the fact that a 30% lithium nitrate solution has 70% water, in fact, the 70% water may be driving ASR more than the 30% lithium is controlling it. So basically, what we showed with this is that topical applications or even ponding really isn't very practical. We continued on to one of our other sites, which is here in Houston, and this is a large-scale bridge here that suffered from ASR. And in this case, we looked at both silanes as a way to try to reduce the internal humidity. And of course, we looked at lithium, which was the source of this funding. But in this case, we didn't want to do any topical treatment. We knew we hadn't had success to date with it. But we did try two more rigorous methods of trying to get lithium into the concrete. On the left-hand side, you could see we hired a contractor who did a vacuum impregnation of the column. And on the right-hand side, we used an electrochemical migration technique where we couple to the reinforcing steel, and then we apply lithium solution for several weeks to try to drive that lithium deeper by tying to that rebar, which is about 2 inches from the cover. Well, in the case of the vacuum impregnation, we got about 1/3 of an inch. Again, isn't going to help you very much with the column, which is say 5 foot least dimension. And when it came to the electrochemical method, we were actually quite pleased to see that we were able to get much higher levels of lithium all the way down to the reinforcing steel. But unfortunately, when you electrochemically treat concrete this way, your rebar becomes a cathode, it generates hydroxyl ions, and the alkalis that are already present in the concrete mix tend to migrate towards the steel to satisfy those charges. And in fact, although we were able to get lithium, shown here in light blue, well above this threshold value throughout the structure, we did see the movement of sodium and potassium on the right-hand side as you move closer to the steel. So the good news is we got lithium in very effectively. The bad news is we pushed the other alkalis to the steel and may have actually caused more harm than good. Our data through now 10, 15 years of monitoring shows that none of these lithium techniques were beneficial at all in suppressing ASR expansion. My last one I'll get to, and I'm going as quick as I can here in the interest of time. We did some work in Boston with highway barriers outside of Boston and Leominster. We selected different sets of highway barriers with different degrees of severity. And again, we looked at different treatment options. Again, both silane and lithium. We used a vacuum impregnation technique to again try to drive the lithium into the concrete deeper. And we looked at a variety of different combinations of silanes and different types of sealers. And in a nutshell, first of all, with regard to our desire to drive lithium in, we were, again, not very successful. Topical applications barely got in, and the vacuum impregnation, again, less than a couple 3 millimeters. So it's just extremely difficult to drive lithium into concrete, even with these advanced techniques. However, we did find that lithium does work as long as you combine it with silane. And silane is a spray-on material. It forms a hydrophobic coating, and with time, it lowers the relative humidity inside. It is breathable, so it allows vapor to get out. And you could see with these Boston barriers that the ones here on the bottom in both cases contain silane, and with time, the relative humidity dropped, and expansion came to a halt. You could see here photos. The left-hand side is control, the right-hand side is silane. Here's another picture, and we have conformational data to show that the relative humidities were well below 80% with the treated sections. So it's an ideal situation for silane where you could treat from both sides and dry it from the outside in. And this is really the single success we had in all of this federal highway funding. So I thought I would end with a good story. This is consistent with experience in Canada that has shown that that treating barriers with silane has long-term effectiveness, both in terms of expansion reduction and relative humidity reduction. And we then follow this up with laboratory testing, and I'm just showing this quickly. This is the NCHRP 244 procedure, where you take concrete blocks, you coat them with whatever coating, and then you cycle them through wetting and drying cycles. And what you can see when you do that is that products such as silane greatly reduce the internal moisture by preventing water from getting in during the wetting cycle, but allowing it to get out during the drying cycle. So we do have some pretty reasonable laboratory methods for assessing products that work well. You could see that the relative amount of absorption of water absorption is a fraction of the straight control mixes. So silanes do work really, really well, provided you apply them correctly. And we have long-term outdoor exposure data to show this as well, that when we see a product such as silane working well, we do see internal relative humidity reductions, and we do see reductions in expansion. So there is some light at the end of the tunnel, but just finishing off with the lithium story, we really don't see any reason to focus on this anymore. We've found very little success in everything we've done with lithium treatments, but we have been more lucky on the silane side, or more fortunate, I should say. There's been a host of publications that have come out of this federal highway work, just shown here. One of the publications that Mike took the lead on was the Reactive Solutions, which is a newsletter that would come out once a month. Mike had the editor's corner and asked the experts. And he had to respond from all kinds of tough questions from folks all over the country, including Michael Hunt here, who had a heck of a question about lithium. And Mike did a really good job with this publication and answering all kinds of questions throughout. Lastly, my last slide here, some facts about Mike. He was formerly the lead singer of the Flying Buttresses. They were a well-known band in very small quarters of the UK. They had a couple of sitting room only shows. And Mike was a really good singer. But then he quit and moved into concrete. Also, Mike sneezes in prime numbers. We've collected data over the years, done some Monte Carlo simulations, and lo and behold, he always sneezes in prime numbers. We need some more data on what we call the wasabi scale, because when Mike eats wasabi, he sneezes 11 or 13 times, but we don't have enough data for a precision and bias statement. Mike understands chemistry better than any civil engineer I've ever met. He's the only one who can recite the periodic table at will. And lastly, I'll finish off with one of Mike's most famous quotes. This was in 2004, ACI in San Francisco, where Mike had uncharacteristically missed his technical presentation at a session the day before. Well, at our ACI 201 meeting, Mike's famous line, he said, "I've slept through many presentations in my time, but this was the first time I slept through my own."